Let's wait for everyone to join. Hello. Am I audible to everyone? Okay. How is it going on the last week assignment? Mm. So they have given this question format also, as far as I remember. Yeah, I am not in that team or anything. It's completely from NPTL, so I don't know about anything about the exam. But that I know that it will be in this um, offline mode, most probably. So offline, it will be in. So most probably it will be problem based, and sometimes there will be some questions of this objective type questions. So those will be there. It will be mostly like assignments. So if you can solve the assignments and see the assignment solutions, then it will be mostly from that and in-depth knowledge of they will check about the assignments. I exactly don't know, but most of the time it happens that that I don't think so that this coding will be there. Coding will not be there. Uh, because in pen and paper it is not possible at all to take it. Maybe they will ask you to write some flowchart or something. But most, hmm? I got it. You got it. Okay. So like this turbulence modeling, there will be a question about turbulence modeling most probably. So if you can, most probably. Uh, if I was there in that team, I could have told you more discrete answer, but I don't know. Maybe in the later stages they will tell me. No, not at all. They will not give reveal the papers. Yeah, they will never. If you have them contacts who did this, who gave this exam previously, then they may help you. Mm. Yeah, then prepare accordingly. You'll be like if you prepared well, then you'll get through this paper because it will not be very tough. That that I know from my experience. It will not be very tough, but just you need to know all the basics and understanding should be good. Then it will be easy for you. It will not be like assignments, that's for sure. Hmm. Hmm. If you don't understand some concept, then previous prior to that, you can contact me also. Hmm. That particular concept you are not able to grasp or something like that. So there are some more. So others, you are good to go with the exam, or I start preparing for that. And having some problem in assignment 12. Assignment 11 date is over. Till 12 date I know. 18th is there. 18th is the date for 12th exam. So we have evaluated assignment 10. We gave good marks in that. Whosoever has submitted. Uh, have you submitted? Okay. It was a good chance to get good marks. Okay, 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 okay. Okay, okay. I got some copies for assignment 11 also. So I think around four, 12 copies. So 12 evaluations I have to do. 12th also. 12th का भी नहीं है. 16, 18. Okay. Yeah, yeah, yeah. But not options. You have to write. Yeah, you have to write. Why? Why that option? Oh, you can resubmit. You can see resubmit. Others, Kripal, Apurv, Preeti. Why didn't you ask in the live session or in, sorry, not live session. Why didn't you ask in this forum? Okay, I'll open it. Mhm. Okay, let's see if I know. 11. Mhm. Just a second. Maybe you don't. Just a second. Just a second. I'm sharing my screen, so can you see this folder? Turbulent flow and heat. Hmm. Yeah. Here? Okay. Okay. I'll see. The big terms. Yeah. Mm. What is exactly the problem we are facing? Just let me know. What you are substituting, and what you are getting. Hmm. Let me check. Let me check. They have substituted this alpha. Uh, yeah. Term 6 is equal to L square plus square. Just mm. No, 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 you can't do it. I don't think that that's the right way. Whatever you are talking. Let me think. I don't remember this, but let me think what they have done. Maybe I can solve something. I can give you some hint at least. So but they put just del u dash by del xk as alpha, and then this half here. So this and u dash by. Hmm. Just let me think. Maybe I can help. Just wait. Solved it a long time ago. I don't remember exactly what to do. Mm, 26. Whatever you have done, what you can do is you can send me this PDF and then I can maybe solve it. When I will write it, then only I can think about more. Mm. Mm. But I think they have just replaced this del square alpha square by 2 as this. So this, if you write it here, this, hmm, 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 hmm. Let me just do it. Maybe possible. So minus 2 mu square del dash by y dash by del k plus into del y del dash by minus k. So minus 2 mu square del u I dash k minus k that is to alpha. Alpha is to dash by minus k would minus that is fine and u dash plus. Okay, okay, I got it. Actually, this is like you put this alpha del square alpha as this. So I'll share my screen. Just wait. I got it. So here in this, they have written like this term as minus del square del u dash by del xk, the average by del square del u dash I by del xk. This term you need to replace, and this is del square alpha square by 2. So you just think like here, this alpha del square alpha as this term. Okay, so this is alpha and del square alpha. This is the alpha del square alpha plus del alpha by del xm by del alpha by del xm. So if you put it, maybe it's like del square alpha square by 2 minus del alpha by del xm by del xm. Del square alpha is this minus 2 mu square. This is alpha. This is del square alpha. Okay. Half because this is alpha. Alpha again minus. Mm, you got it? Yeah, yeah. This is so you have to think in a different way. Just alpha del square alpha is this term, sixth term. This is alpha del square alpha. That is why they have replaced it. You got it? Okay, fine, fine. Others? Sir, even sir told in the lecture this is tedious and difficult to remember. Yeah, yeah. Sir, regarding should we write the question and read it option? Is it the right format since instructions aren't specified? I want to know. So first, Preeti, this sir even told, yeah, these questions are bit quite tedious and something maybe ask from this. I don't think that they will give you this big derivation because there is no point of remembering these things. So they will give you some questions in which you need to, like I just brainstormed about this question. Something like that maybe they will give. And about the Krishna regarding the assignment. So what you can do is you write the question, then you write the options, correct option, whatever you find it, and then some part in which you can say that, or let me check it how the previous students have sent it. So how solution is there. Mm, I have this in my hand. So what they have done is some questions they have derived it. So like one question is about Reynolds averaging. So they gave the term why it is becoming zero, and so they gave the derivation. And um, in some questions, you can just refer to the derivation is in which material. Suppose in material one of the turbulence, you have this answer. So you can just like suppose they ask about the thermal diffusivity. So you can just refer that it is in this resource material, or you can refer about the derivation. You don't need to write derivation, but if you are writing that answer, just write the correct explanation and where it is in the material. You don't need to again do redo the this thing derivation part. Derivation is quite tedious about for assignment 12. So don't do a derivation. You just write from where you are taking it. You know the material name, week 12, first material. So that material in which phase it is, you just write that. And if you just refer it, it is good to go. If you know the answer, you write the answer, correct formula. Okay. So another. Yeah, don't need to remember those empirical relations. There's no point of remembering. I also don't remember. Nobody remembers. There's no reason to remember those empirical relations. Sometimes in GATE and all they ask about some empirical relation, but I don't know. I'd never uh, encountered any question from any professors about turbulent empirical relation. They in our college they mostly give open book, so there's no we never remembers. And in this also in NPTEL test, I'm very sure that they will not ask you about empirical relations. Don't remember it. Don't. And if they ask, just leave that question. No, 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 no. It is very tedious process. It will not be asked in exam if you're just talking about the exam sense. And if you are talking in this practice sense, you can always do any coding. There's no limit to it. But modeling part, nobody does it. Most of the people take it from internet and just use it directly. This K omega, K epsilon, and suppose other models are there, dance model, simple dance model. So they directly use it. Like also this, whatever I have given, the material I have given in the lecture, this MATLAB code and all. Um, this it is for the practice purpose only, so that if you encounter some new problem in future, you can directly provide the solution for that problem. So you have the experience. But those things are available in internet also. So have you in the course, did you got the lecture about structured and unstructured grid? Do you know about structured and unstructured grid? Not staggered. Staggered, though I taught in my live sessions also. I am talking about a structured and unstructured grid, where we use structure. No, structured means Cartesian grids are there, and unstructured means this triangular and pentagonal, any type of grids structures can be there. There are three types of grids also. So, do you know about these things or not? So let me. Okay, okay. So there are structured and unstructured two types of grids are there. Whenever we do this um, CFD of any of the geometry, so there you can do structured and unstructured grids, or you can make. So most of you have used ANSYS. You just go to ANSYS, right? Don't right now. Like I'm asking, whenever you go to ANSYS and try to just automate the meshing process. So in the starting, it will generate some kind of grid. It is most of the time it is unstructured grid. Sometimes it will take like this type of elements. So suppose you are doing for circle, so it will take like this, and in the starting it will just do some kind of structures and it will make. So it is called as unstructured grid making. So it is mostly undesirable in simple geometries and even in the some complex geometries. It is most of the time undesirable, but sometimes we can't ignore it. So we have to compromise between some part in which we can do this structured grid or some part we can do the unstructured grid. Why it is undesirable? Because it is extremely difficult. So whenever we coded in the last time, in the whenever I gave lecture in this, so we have this matrix formations. Matrix means we know I, we know J, we know the row number of the nodes. So you know about the nodes number and the matrix structure. But whenever you go for the unstructured grid, you don't know about the matrix of that. So it will be really difficult to analyze about the neighboring cells and how the flow is happening from one cell to another. So that is the main limitation of unstructured grid making. So uh, Right now, we have learned only about the structured grid based on the Cartesian coordinates, and for our derivation purposes or coding purposes, we have learned about it. Uh, So, similar structures can be used in other coordinate systems such as cylindrical and spherical. Those are also called the structured grids. If you are using a cylindrical coordinates, they are also in the cylinder or and the sphere. You can talk about the neighboring cells, IJK, matrix formation, everything, because you have this. Suppose you have circle. So in circle, you have this I plus 1. So whenever you make matrix, what you do, you just open it. And it will be like neighboring cells after opening. I plus 1, I plus 2. This kind of structure it will make, and you know the neighboring points. That's a main concern, that you know the neighboring points or not, neighboring node point or not. By that, you can define the properties of that node, and after that, you can solve the equations. So, in unstructured grid, solving those equations will be really difficult. So, we try to make mesh as structured as possible, as far as possible. Okay. So, yeah. Uh, Generally, there are two types of grids of structured and unstructured. But in structured, there are several parts. So, you can say that Cartesian grid is a subset of that structured grid. So we have used specific type of grids based on the Cartesian coordinate system, just a small subset of that Cartesian grid or structured grid. Sorry. So um, domain, as we represented by coordinates line and grid points, are placed at the intersection of the coordinate line. So what I am telling is, so I'll give you notes about it. I am not writing. So at this point or at this point, you have the nodes. Uh, Another thing is, so interior grid points have the same number of neighboring grid points. This is known as some connecting point. So why I'm saying that or coining that point as connecting points means you know the neighboring point, you know the previous point, everything you know there. That is the main point. So you know the next control volume, whatever we are making. So suppose this is our control in this staggered grid arrangement. Suppose you have this control volume, you have another control volume, you have another control volume. So you know the neighboring control volumes here. So neighboring control volumes actually gives you an edge while doing the structural grading or while doing the meshing or while solving the equation. This helps you. While like you make a matrix and after that you solve, then it helps. Um, so examples are, one thing is Cartesian grid. So these are for examples of uh, structured. So this will give you some base about grid, at least in the end of this course. Cartesian, cylinder, cylindrical, and then spherical, and one more is orthogonal and curvilinear. So what you can do is you go to internet and search about each of this so that you will get to know about different grid structures. I'll tell you some, like in Cartesian you all know, Cartesian grid and rectangular grid you know. But mm, so these are for regular structures, regular geometries, and for irregular complex geometries, we need this some other kind of approach. So one is called as uh, step uh, stepwise approximation of the profile. Okay. Uh, how can I say? Yeah. This is another good example. So suppose this is our domain, or I will not make domain. This is our cylinder, and I want to do this. This looks like it. This is our cylinder. Okay. Cylinder I am making, and here I want to do this structure grid. So how to do it? I will do. I will segregate it in small parts, or I will just bifurcate in these parts. Okay, like this, the stepwise manner. Okay, so at the end, this portion will look like a cylinder. If you do it in a very infinitesimal small sections, so these sections will, at the end, when we merge it, it will look like a cylinder. And what we will do is, so we make a big domain. So why we do this? Whenever we do this flow over cylinder case, this is suppose a flow over a cylinder case. So if you code it, then what will happen is you just give the initial flow from here, okay? And when initial flow is coming, you want to know about the drag it is applying on the cylinder, and the suppose if you are solving this heat transfer problem, you want to know the surface heat flux. If you are solving fluid mechanics problem, you want to know the shear stress at the boundaries. So you don't want it to be affected by the wall. So that is why you make a big domain. After big domain, these walls are not affecting this, and so if you just do it like this, the grids are meshing like this. So this at the end will make like a over a cylinder case with structured grids. So that is my whole point. Uh, this is really important. If any one of you don't understand this, then let me know. Are you guys there? I am talking about. No, 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 no. We can do anything, but I am right now talking about the structured grids. So we can uh, right now we can just do this with cylindrical coordinates directly. Coordinate transformation is another thing. It's the way. But right now I'm talking about a structured grid only. So you can just define it like with structured grids so that the problem will be a bit easy to solve. Now suppose you have airfoil. Mm, Airfoil structures, airfoil structures. So if you have this, you can again solve it like this in a stepwise manner. You make this airfoil, see the flow over an airfoil, and how it is moved. This is basic way of doing it. You can do with unstructured also, but right now I'm talking about why I'm telling you this. The thing is, If you do with go for a complex method, then you need more storage. Storage is one of the thing in CFD. So you have to save your storage. That that thing should be in your mind while solving any CFD problem. That storage right now, suppose here if I just make this, I don't make a big domain here. So while we solve the aerodynamic problem like this, flow over and airfoil, the problem which occurs is we have to take domain 5 or 6 times the airfoil, so that our flow is high speed flow will not get affected by the walls. So for each and every bits, you need to save that data in your system. And that data storage is another problem. It's a big problem while solving any CFD problem. So, uh, but here it is a compromise also. We will get some error at the cylinder wall or at the airfoil wall. But sometimes you want to make a compromise to save the storage and get some errors, which you will report that I'll my um, solution is 50% correct. Oh, sorry, 95% correct and 5% error chances may be there. So these errors, runtime errors are there, and computational efforts are more. I just wanted to introduce you to these topics so that there are different kind of grids. So in airfoil, uh, this is another kind of Cartesian grid you can use, where this type of structures are there. So this is called as, I think it is called as H-type grid. Uh, you can learn about this. So it is always orthogonal from this surface. Orthogonality will be there. And here also it is called as structured because you can define I plus 1, I minus 1 here itself. And if you open it, you can define. And similarly, you can define the control volume, and this will be ij plus 1. So this kind of things are there. Mm, body, it's called as body fitted grid, I think. So I want you to read these things. Um so there will be one in structure itself, which is called as non-orthogonal curvilinear grids. So here you define grids like this, okay, and this is the way. So here also you can define IJK and everything. And orthogonal measure. So let me write it. This is non-orthogonal. This is orthogonal. So in unstructured, no structured or coordinates lines are there. So number of neighboring cells are not defined. For suppose this is unstructured as I made in the starting. This control volume can have 1, 2, 3, 4, 5, 6, 7 neighboring cells, and this can have 2, 3. So it is never defined how many control volumes has this control volume has as a neighbor. So no limitations is there. In general, we have this triangles, quadrilateral in 2D, and tetrahedral and hexahedrals in 3D. And it can be a mixture of these two hexahedrals and tetrahedrals. So suppose I have this similar airfoil structure. This can be defined like this. Something like that. And here you don't know about IJK and everything. So you have this. This is the unstructured one. Got it? Got the difference? Yeah. I have one previous lecture in which I have talked about C-type, H-type, and O-type grids. So that I will explain. You can just learn it online. So I want to know. Mm, oh, oh, that is another type of grid. It's not a structure. Not always. Oh, what happened? Can you see me? Yeah. So that is another type of grid. It is pure triangular grids. So there you can talk about the centroid of the center and take it as a control volume. But um, it's a manual thing, so you have to define like that. Nobody like most of the time I've never seen grids like that. So either it will be yeah, triangles are there, but quadrilaterals I have seen most of the time. So what I want to convey is before your exam, you can, if you have these kind of questions, you can mail me because I have not got any mail. Last time also you called, you said to me that you'll mail. It's fine for me. It's an easy way to go. But for you, if you have some doubt in exams, then think about talking to me. Any of you, whosoever is giving exam. Yeah, can't hear you, Apur. No need, no need, no need of this. No need of that, Elias. No need of Elias discussion because if you know the RAMs, it will be the starting point of that. And sorry, direct numerical simulation will be the starting point of that. So uh, don't go into that. LES is just a turbulence defining term in which you will define turbulence in a large eddies. You will not go to the this smaller eddies which can dissipate at the end, but you will capture the larger eddies there. So there are different models for that. And you have to start your solution with direct numerical solutions, direct numerical simulations. Like you have to start your simulations with the Navier-Stokes equation solution directly. You have to solve it, and after solution, you start means with the viscous term I am talking about. It's a very difficult or most computationally expensive way to start with, and then you go for the LES models in which they will capture the larger eddies, which you can further analyze. That's the main point of LES. There is no point of discussing that in this forum. It's a big topic and it's a big subject itself. It's like Rance. Rance took around some weeks to complete, you know. Rance is still not clear to you. I think you know about K omega, K epsilon completely. What is K? What is epsilon? Hmm. Mm-hmm. 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 Yeah, that is fine. I think for the starting purposes, why you are going too much in turbulence? Turbulence, it's a big topic. It will take around some weeks to complete that topic. So it's not that easy. And LES, you were asking that I told you about the starting point of LES, which I also learned after some experience. But this discussing the equations will be, it's a big task. There's no point of discussing here. Obviously, obviously. No, no, it's a differential equation thing. LES is a differential equation. So here, let me search about LES. Hmm. No, no. Here, the starting point is only Navier-Stokes, but there are you filter the large eddies, smaller eddies. You filter it out. So, which is called as this. Uh, I'm, I don't remember. So these are the governing equations. Kinetic energy equation. I'll not discuss those things, Apurv here. There's no point of discussing. Others will get confused, and I don't want them to, because this is completely a research topic. Why you are this? We should not go inside. No, that's fine. You can ask me in separate mail about Elias. Even I don't didn't work ever with Elias. I know about it, but I never worked with Elias. You can work with direct numerical simulations. You can work with runs, but Elias is completely different research path if you are going on that. So it's a completely different thing. No, finite work. Okay, DNS. It's easy with finite difference, but you can go with finite volume also. There are methods called DES, direct element solutions, and you can go with that. So fine. If you have further questions, you can ask. Either we can leave with the meeting right now. Which assignment? Can you tell me the number? Square cylinder. I uploaded solutions. Mm, I uploaded already. Just tell me the assignment number. How can I remember? I uploaded 11th assignment's solution also. Yes, today only. No, yesterday I uploaded. Are you asking about this? Let me share it. Stop share the window. Are you asking about this assignment 11? Tell me assignment number. I don't remember these things. Okay, whenever you remember, you send me a mail. Maybe if I have particular solution, I can share it with you. 8. So you want this coding for this? Code for that? Okay. Maybe if I have, I'll share it in this group. I'll look for that. I'll share it in group. Okay. In which I'm sharing my notes. I already shared this week 12 unstructured grid and structured grid like notes, initial notes which I made. Others, maybe I'll share a small lecture also there, and whatever you asked for it, assignment 8. I'll just look for it after this class and upload it. So, okay, bye. Good luck for exams. You know my email ID. You can send me email. And yeah, yeah, please. Yeah, fine. All of you can ask me in the mail section. Okay, Apur, thanks for the interactive classes. You got like you asked very good questions, and others also. It's fine. But it's sometimes engagement is necessary. You lost your interest, and if you ask question, it makes the class more interactive and more knowledgeable. Sometimes people ask question which I don't generally answer, like you asked once about this other particle modeling things, and right now you asked about the ENS and all. I think that it is not necessary to tell, but yeah, it will increase your everyone's knowledge. Okay, take care. You can ask me in email. Again, I am saying. Okay, bye.